share screen, and that would be here. Okay, so I will send out all the answers as well. I will send after the class the whole presentation to you because I know that is something that is useful. I suspect you would have liked to have had it now for writing notes and such, but I actually have the answers embedded, so it will be something that you'll have after this class and you can refer back to. Our test afterwards will be open book. Therefore, you can use as many resources as you can. I just ask that you don't share the exam with others so that they get an equal opportunity too. And then after that, probably as I look at my calendar, September 20th, we will be sending out the challenge set. That challenge set will serve as practice on an organism. It's not the real thing. I always use mimics, but it serves as a practice opportunity to work on the flow charts that we'll be teaching, that what we call the LRN protocol. It will give you an opportunity to do it just like we would if we had class here and I would have a wet lab. So you'll be probably doing anywhere from 2 to 3 organisms that you can try. It's not graded, but I want you to see how far you can get with them and to see if you can recognize it after learning all the different trigger points of these hazardous organisms we'll talk about today. So let's just take a few minutes and go through the bio safety part of it. I must let you know that the first number of slides before this I shared with you as well, because we won't be able to cover those today. It's something I always have covered when I was on site or had class attendance here, but we will not go through them to save time. But I think that most laboratorians now, especially after COVID, has a better handle on biosafety. So it's more a self-study. And I want you to go through it because there will be some questions on the exam, although open book. You can look at them, but they will be on the exam as well. And if you have questions throughout looking at those slides, you're welcome to call me at any time. So we're going to go ahead and jump down through the first part of those slides. That is going to be study, and the things I wanted for biosafety review were these slides. And so we're going to go through them now. The first slide I had was what was wrong with this picture. I thought you guys did a fabulous job because you even taught me one that I didn't see in here. So I'm very happy to know that. What is wrong with this particular biosafety cabinet? Obviously, there's things right on the grill. The grill is obviously your best protection. That air that blows from the HEPA filter inward, it goes into the biosafety cabinet is for you to be protected. And so if you've got something right on that biosafety cabinet grill, you're going to have a breach there. That's where air can seep out toward you. And obviously that is not what we want. I am guilty of this, and I have seen people put their protocol right here so that they can refer to it as they're working on a procedure, and maybe not as familiar with that procedure, and that's just a no-no. So again, protect yourself, make sure there's nothing on the grill. Too cluttered was number 2. And obviously you can see that they're using it for storage in here, and that is exactly what you don't want to do. In fact, in between times, pretty much everything should come out of there except maybe the items you would use at all times. But most things, I guess, should be out of there. And you literally want to plan ahead, decide what equipment you need, and then bring it into the biosafety cabinet. Now, granted, sometimes it's easy to forget, but it's important to be sure that it's not too cluttered, that you only bring in what's needed, because if you start packing in things, you see there are grills. Not only is there a grill in front, but there's a grill on the side, there's a grill in back, and then a grill on the other side. You don't want to block these at all. That allows for seepage again, and not good airflow that is meant to take any contaminant that might get in there. It would normally take it to the top to the HEPA filter again. So that was number 2. Number 3, well, I guess I mentioned number 3, don't block the back vents against the walls or the sides, simply because of what we discussed. Number 4 was a tough one. Some of you might not have got it, but this is definitely a consideration. So you see that through all this junk, there is not one disposable container. But you see one outside of the biosafety cabinet, which is really a no-no. You should not be reaching outside of the cabinet and then throwing your stuff away. Because the rule of thumb is if you come out of that biosafety cabinet, you should be taking off your gloves first before you do any other project. And that's just a fact of life. It's something I did not know when I was in the clinical lab, and probably did a million times. But you think about it, you come out and let's say you think you're just gonna go get one item that you have forgotten. However, then you get a phone call, somebody needs to talk to you. And here you are, before you know it, you're touching something else. You have just come from the BSL-3 and now you're contaminating everything in your laboratory. So a good rule of thought here is that every time you exit that biosafety cabinet, you should be taking your gloves off first. So in reality, you should have it planned well enough that you have all the equipment in there, that if you've forgotten somebody, ask somebody to help you. The only time you go in is at the very beginning. Anything that needs to be disposed of, you should have a small disposal container in there. And then at the end of all your process and protocol, when you're done, make sure that you clean correctly, that you disinfect the things that need to come out. Always work from dirty to clean. And then when you are ready to come out, then come out, take your gloves off, wash your hands. And if you still have something in there, you just need to reach in, put a new set of gloves in, bring them out, and go ahead and do what you need to do. The last one, number 5, was that the sash. I didn't realize it, but you look, here's their yellow line, if you can see my little arrow, and the sash is way up here. Obviously, that might have just been because they weren't using it at the moment they were taking pics. But if that's where they're leaving it, obviously it's going to be bellowing with an alarm, hopefully. And they will have air leakage if they really do continue to use it this way. All right. Any questions about that first one? Feel free to unmute. Okay. Hearing none, I'm going to go to case number 1. If you read it through, this was a researcher who was healthy, who was young, who had he been working a little bit more carefully, or let's put it this way, maybe even been taught more carefully by his PI, this probably wouldn't have happened. But this is a true story of a gentleman who died because he was working with Neisseria meningitidis. And that's not even one of the organisms that I'm going to be talking about today, just briefly maybe, but it is still one of the most hazardous organisms in the laboratory. And so in reading through it, you know, it came quickly. He had septic shock by 24 hours, and unfortunately had died just as or before he got into the emergency room. Well, what were some of the things that could have been done to save him had he been taught properly? Well, here's the answers to the observed practices and what you might have put down as recommended practice. He was using a slide. He was flaming the gram stain slide to fix it. Obviously, flaming is not even allowed in a laboratory, but unfortunately, I think some researchers still tend to use it because they might not want to spend the money on one of the core incinerators that you can use in a laboratory. So the first thing they really should have done is maybe allowed the slide to air dry. And you should do this with all your specimens that you do in any microbiology, not just these hazardous organisms, all sputums, all blood specimens that you're doing on your blood bottles should be air dried first and then brought out. If you try to do it by the flame, obviously that is not, it will fix, but it's not a very predictable temperature. You could fry the organism or opposite, not fix it enough. And another reason why we don't use an open flame. In the fact it's just dangerous if you're working with anything else, alcohol or whatever, you don't want an open flame in there. There's been a lot of catastrophes that happen if you have alcohol in that particular cabinet too. So you'll want to either use some alternative method like methanol, alcohol fixation, or use a heating block. Ideally, it's even better to have a heating block inside the biosafety cabinet, but so many people do have small ones. And so then you could think about it, but you have to do a risk assessment first to see, do you do AFB? AFBs need 2 hours of fixing on the heating block. And you're not giving the same specimen that you might be doing for BT or anything else, or just even blood cultures. You're not giving it those 2 hours. So you really need to think about if you've got your heating block outside of the cabinet, then it will be a little bit more of a danger than if you had it on the inside. All right. Plate spreading is not something that most laboratorians do anymore. That's kind of, again, the old-fashioned Kirby Bauer method. Still, there's some work in the research laboratories to do the plate scraping. Of course, just picking up a colony can be considered plate scraping. So instead of a plastic scraper, they should use cotton swabs because it really does generate aerosols. Plate spreading is used for old-fashioned colony counts, and so they could count the colonies, but it's the same story. It generates, when you do movement like that on an open bench top, you are at risk to aerosols. We've talked about flaming. Flaming your loops to disinfect them is just as dangerous. It does cause aerosolization. And so by far that incinerator or some electric furnace system or piece of equipment is by far the better one to use. Now, a lot of laboratories have gone to disposable. Those are pretty nice. I must admit, I'm finding myself, even though I hate throwing away that much plastic, finding that sometimes it is more convenient. But then you have to think about, okay, where am I going to throw that plastic? I can't take it out of the biosafety cabinet every time I want to dispose of it. So you do need some sort of a small disposal in your biosafety cabinet. Resuspension of solution, if you're making anything within that biosafety cabinet. They talked about enzymatic reactions for 10 minutes. That could be for using the MALDI, that could be any research project or doing PCRs. And so the manufacturer may recommend 20 to 30 minute time treatment for enzymatic reactions. So please don't cut that time down. Open discard bin, I think that we've talked about, sufficiently. Definitely have something inside. And then when discarding these things, all the equipment that you use, whatever it might be, even if it's just a regular loop, you have to make sure it's disinfected, and then at the end of the task, take it out carefully from the biosafety cabinet. So I hope that answers those questions. Any questions about that? All right. You could be comparing your own notes. Now, I did not grade them because I just wanted to see if you could make it through. And it's more of a learning process than if you got the answers wrong, you found out the right answers today. All right. The second case was about a gentleman. I found this just very interesting because it shows that you just don't know what can happen. This is an organism that we use in laboratories. It's an attenuated strain. We use it in our public health laboratory on occasion for QC. So to know that if you are autoimmune or if you have any other underlying diseases, would be very helpful to know how safe you are working in the biosafety cabinet. This particular gentleman may not have known, however, that he had this unusual disease where his body seemed to collect iron and had an overabundance of iron. So that particular disease, if you read more about it, that's essentially what what did they call it? Hemochromatosis or something like that. And he, when working with this organism, didn't probably realize that this particular strain of Yersinia pestis, the way to make it attenuated is to take the iron out of it. And so it's not harmful to other people, but for him, he had so much iron that it probably somewhat just absorbed his iron. So that's what's so unfortunate. And it did unfortunately kill him. So some of the questions that came up as who's affected and what was the causative organism disease. Well, it was this organism he was working with that was supposedly attenuated, right? All right, but because of unusual circumstances, it still was not attenuated to him, unfortunately. So the contributory factor to exposure to death was just that he probably did not work on it properly, did not do everything in the biosafety cabinet. Again, he probably didn't even, realize and the aerosols that he was performing outside of the biosafety cabinet. Unfortunately, this did kill him several days later. What could have been done to prevent these things? Well, if you think about it, the previous Neisseria meningitidis case, one thing that could have been done is to be vaccinated for Neisseria gonorrhea. It's known as the gonococcal vaccine. We give it to our teenagers now or people going into the service because we're afraid of them when they're in college settings or playing football, and they're in close quarters to each other. And this is a disease that can go through classroom settings. So having that vaccine not only should be for those age groups, but it should be for every laboratorian. And I certainly hope that every one of your laboratorians does offer that particular vaccine to you before you ever work with this organism. And in the clinical lab, you may or may not ever know if you have that organism in some of the clinical specimens that come through. But working preventative measures, doing everything by the book may seem overkill to you, but in reality, it's to protect you. So hopefully I answered these all. These are pretty much the answers to these questions, and I'll be sending this out as well. So the biosafety practices of wearing gloves, taking your gloves off after every time or right as you're exiting would help to prevent that transmission. There's other things safety-wise that we kind of talked about in the slides beforehand. If you have a really tight, small lab, if you've got people walking as close as 5 feet behind you, believe it or not, their walking can be faster than the airflow that's happening in that biosafety cabin. And they, with their treks just across the back, can pull from that biosafety cabinet and can pull out organism, which then again makes you susceptible. So I have asked our biosafety officer to kind of sit in and think about or answer any questions that you guys might have. Jen, did I do it in what am I trying to say, in summary form? Did I hit everything possible?
You did great. Nice job, Karen.
Oh, well, can you think of anything right off the hand, though, that I didn't mention that's really important?
I think one other thing just to mention is always being cognizant to wash your hands before you leave the lab space after handling any organisms. Even if you had gloves on, it's just best practice of anytime you're done and you're getting ready to leave the lab or switch job tasks is to wash your hands.
Yes, and very true. So thank you for that information. Okay, so I've got one other comment to make about case number 3. I did have you read just a small blurb, small pages 529 to 41. There was a lot there, but what I really needed you to gather from this information is that there is some new biosafety regulations that I learned about by sitting through Sean Kaufman's class. So something called the BMBL, which you might not be familiar with, is kind of the Bible to all of biosafety rules in clinical labs, in researching labs, whatever. But when it comes to considering the biosafety levels, obviously, you have to think about doing what we call risk assessment. Well, in the past, the risk assessment was just left up to the laboratory manager. Nowadays, that is not true. So CLIA coming through, CAP coming through, COLA coming through, any of those accrediting agencies may ask to see your guidelines or your paperwork in doing a research assessment. And what there's recommending is that laboratory leadership should not conduct risk assessment alone, that you should depend upon the knowledge and expertise of not only your laboratory staff, but your infection control, your safety people in the whole hospital or laboratory, if you're set apart from a hospital. There should be some sort of disciplinary team that helps you make those decisions. And they want you to be sure that all of the people possible that could assist with your risk assessment be signed off on that risk assessment as well. So it's a tough one, but I think that it's good to get a lot of people's advice on it, and it is good to know. So the other questions I had on the other pages was just for you to pawn over. Do you include a safety officer? That's not for me to know, but you to think about. If you don't, I highly recommend it. I want to make sure that some of your laboratorians are trained in the what we call that LRN protocol, that they recognize the suspicious organisms. Is there anything in your laboratory that you might like to improve? And don't be scared to ask your supervisor, lead tech, or whoever. And I think you'll find that once people talk about it and bring it to everybody's realization, they'll go, oh yeah, maybe we should be thinking about it this way. So I do encourage you to work on things in your laboratory that might not be of a best practice, and you've got to talk about it amongst yourselves and see who best could mitigate the situation. One thought might be you have a physician that likes to walk in with your his cup of, or her cup of coffee and walks right through lab. Obviously, don't be hesitant to stop them at the door and say, no food or drink allowed. So that is it for my slides here. Any other questions or comments about those particular slides? Again, if you haven't really thought about looking or have time to look through the front first 50 slides, do take a moment, read through them. We will have some questions on the exam regarding those. But any questions? Okay, all right. Hope that all made sense. Okay. Well, give me a second. I am now going to do a new share, and we are now going to